Hypothesis testing is a statistical procedure that allows us to conclude a population by experimenting on a smaller subset of the population. And in this lesson, we will look at the chi-square test, a sort of hypothesis testing which compares observed and expected results. The goal of this test is to see if there is a mismatch between observed and expected data due to chance or relationship between the variables you're looking at. We will also investigate the applicability of the chi-square test and conduct some hands-on work with it. And if you are someone who is curious to know more about it, stay tuned as we are about to solve all your doubts. So without any further ado, let's start the video. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Suppose your family is going for a vacation and you have been assigned a task to find out the best or cheap and best flight for your family. What you will do? Will you go to browser, open any travel agencies and book your flight or ticket? No, you don't. You try and find the best deals for your family. Similarly, suppose it's a Sunday and you are going to buy some vegetables for your house. Will you go to any vendor and randomly pick vegetables? No, you do not. What you're gonna do? You will choose multiple vendors. You'll go one by one to them, and then you will identify which vegetable is fresh in the market, as well as at a good price level. Similarly, suppose it's your birthday and your father said that go to some mall and buy some t-shirts or top or a jeans for you. So will you go to any mall and directly choose a random shirt, t-shirt or pant? No, you will not. What you will do, you'll go to different shop across the mall and then you will identify the best shirt or a t-shirt or a jeans which suits you. Similarly, in case of machine learning and statistical model, we do not go and directly train our model on the raw data. This is not the data science principle which we should follow. What we should follow in data science principle, we should go and pick a data. Then based on that data, we will do the basic data pre-processing like removal of null values, cleaning of the data, filling the null values with some other values, things like that. Similarly, then what we'll do, we will do the basic EDA, where we will be doing some univariate analysis, bivariate analysis, and based on that, we will pick the best variables, which will help us, which will help our model to identify or to get the best result out of it. So, hello everyone, my name is Shrikant Kumar, and today in this course, I'll be covering chi-square test. So, without wasting any time, let's get started.
Statistical test helps us in comparing the observed data and the expected data. Based on the type of data, we choose the type of statistical test. In this session, we will be covering what is statistics, what is population and sample, what is inferential statistics, what are continuous variables, discrete variables, parametric and non-parametric tests, hypothesis testing, what is chi-square test, properties of chi-square test, applications of chi-square test, p-value, steps to perform a chi-square test. Then we will do some of the mathematical exercise. What are the advantages and disadvantages of chi-square test, limitations of chi-square test. So without wasting any time, let's get started. So let's hop into our first topic. What is statistics? Statistics is a field of science which collect, analyzes, and interpret the data or variable or a record. Statistics is everywhere. Statistics can tell you whether there can be rain tomorrow or what could be the probability of having a sunny day. Similarly, it can also tell you when Bitcoin is going to hit its all-time high. OTT platforms use statistics to recommend movies, web series to their subscriber. Statistics can further be divided into two parts: descriptive statistics and inferential statistics. Descriptive statistics deals with describing the data we have collected, whereas inferential statistics deals with drawing a conclusion about a population based on the data we have collected from a sample of sample population. What is population? Population is something which we can count. It is not necessary that something which we are counting should be living thing. It can be non-living thing. How many parks are there in a city? Parks are non-living things, but we can count the population of parks. Similarly, in Delhi, a total 19 million human being lives. So this is the population of human beings in Delhi. What is sample? Sample is nothing but a subset of population. In terms of statistics, we take samples from population to perform statistical experiments. We cannot select a particular subset of a population to perform statistical test. Suppose we have selected a particular subset of a population. As a result, our output result will not be the correct. Sample can be taken via various techniques such as stratified sampling or random sampling. Random sampling is one of the most popular and used technique in which we select the sample data without knowing anything about them so that there is no bias in output sample data. On the other side, in inferential statistics, we draw a conclusion about the population using a sample data. So, what you do? You took a sample data from an entire data set, and on that data you perform the statistical test, and that result is the conclusion about the population. Let's take an example. During the first COVID wave in India, various state governments and central government wanted to perform an experiment to know how many percentage of people are herd immune. To perform this test, for example, in Delhi, the population of Delhi is 19 million. They took a sample data, let's say 0.1 million people, and based on the result from those 0.1 million people, they came to a conclusion that 90% people are herd immune. So that is an example of inferential statistics. Another example, we can say that suppose you want to find out the average salary of data analyst across India. So there are two ways. Either you can get all the salaries of data analyst across India and then you can find the average. That can be an example of descriptive statistics, which is a very difficult task to achieve. On the other side, what you can do, you can identify the major IT cities, and from those major IT cities, you can pick the companies where they hire the most number of data analysts, and from those data analysts salary you can find out the average salary, and then you can say that on an average in India this is the amount of salary for a data analyst. For example, let's say if it comes at 30,000, so you can say that on an average in India the data analyst's initial salary is 30,000. Now let's move on to our next topic, which is continuous variable and discrete variables. In mathematics, variables can be divided into continuous and discrete. Whenever we perform some activities of measurement, the result which we get is continuous in nature. For example, suppose you wanted to know a height of all the students in a class. So what you'll do, you will call all the students one by one and then you will measure their height. Now suppose one student's height is 5.6 inch. Can you say that the student's height is precisely 5.6 inch? No. We cannot say that the student's height is precisely 5.6 inch because there can be infinite number of values between the minimum and the maximum of 5.6. Continuous variables are quantitative in nature. Similarly, when we are running an experiment to count the male and female participation in an activity, what we do, we categorize the participants into male and female and we count their frequency, and then we draw a contingency table. Such kind of variable is known as discrete variables. Discrete, well, discrete variables are qualitative in nature. By binning the quantitative variables, we can group them into different beans And by doing this, we can convert them into discrete variables. Discrete variables are qualitative in nature. Now let's move on to our next topic, which is hypothesis testing. The purpose of inferential statistics is to draw a conclusion about the population by performing statistical tests on the sample data. Hypothesis testing is a purpose by which we provide enough evidence to draw a conclusion about a population. To understand hypothesis testing, let's take an example. Suppose there is a pharmaceutical company. They created two medicines, medicine A and medicine B. Let's take an example to understand the hypothesis testing. For this purpose, we are taking an example of a pharmaceutical company. Let's suppose there is a disease named X, and a pharmaceutical company just manufacture two drugs for that, drug A and drug B. Now let's suppose that 10 people were chosen, and they were given drug A, and 10 people were given drug B. It was seen that people who took drug A took 30 days to get recovered. On the other side, people with drug B took 20 days to recover. So it was seen that there is a difference of 10 days. So the company claims that there is a difference of 10 days in drug B. So drug B, the patient who took drug B can recover faster by 10 days as compared to drug A. So in order to check this evidence, it was again performed the same exercise. So drug A, drug B. So 10 people were given drug A and 10 people were given drug B. Now this time it was seen that the people who took drug A were recovered in 20 days. On the other hand, people who took drug B took 40 days to recover. So now it was seen that there is a 20-day difference, which is in a completely opposite manner. Earlier, B was smaller than A. Now A is smaller than B. Or we can say patient with drug A are recover faster by 20 days as compared to drug B. So in order to just check once again whether there is no error in calculating the days to recover by patient A and patient B, so they took another 100 samples where 10 people each time uniquely selected, and they were given the same drug, drug A and drug B. And it was seen that on an average each time patients with drug A were recovering faster than drug B. So we can say that hypothesis testing here is failing. Here in this example, our null hypothesis is that people taking drug B on an average recover 10 days faster than people taking drug B. Hence, we can conclude that null hypothesis is a claim or a statement about the population. Similarly, alternate hypothesis can be defined as alternate hypothesis is a claim or a statement with which we can statistically analyze and we can discard the null hypothesis. Here in this example, we can see clearly that people taking drug A are recovering faster than drug B, so we can reject the null hypothesis. Now let's move on to our next topic, which is parametric and non-parametric tests. Now we have a fair bit of understanding about what is a statistical test. Now we will see how we can classify statistical tests into parametric and non-parametric. So before we go and discuss about what is parametric and non-parametric test, let's try and understand what is parameter. A parameter in statistics is nothing but a fixed measure with the help of which we can describe the population. Parametric test helps us in making an assumption about the population from which the sample is taken. In parametric test, we assume that the population is normally distributed. Some of the examples of parametric tests are t-test, ANOVA test, correlation test. On the other hand, in non-parametric test, we don't have any information about the population data. They don't follow any distribution. Some of the examples of non-parametric tests are chi-square test, Friedman test. Now let's move on to our next topic, chi-square test. For numerical data, we use statistical tests such as t-test, ANOVA test to measure the fit of numerical data. But how can we measure the fit of categorical variable such as tax bracket, academic degrees? For For measuring the fit of categorical variable, we use chi-square test. With the help of frequency table or contingency table, we can establish a relationship between the two variables. However, sometimes it is not an easy to establish a relationship between the two variables. So in such situation, statistical test comes and helps us to identify whether there is any relationship between the two variables or they are independent groups. It is used to identify whether the distribution of categorical variables are different or same. Hypothesis test statement for chi-square test is such that H0, which is null hypothesis. So what null hypothesis says? Null hypothesis says that group 1 and group 2 are independent to each other. And what is alternate hypothesis? Alternate hypothesis says that the two groups H1 and H2 are dependent. Chi-square test follows chi-square distribution. Now let's try and understand what is chi-square distribution. So chi-square distribution is a continuous distribution with degree k. So we can also say that chi-square distribution is nothing but it's a square of standard normal distribution. Okay, let's try and understand that. We know that standard normal distribution is nothing but a normal distribution with standard deviation of 1 and mean of 0. So let's first is 1, second is 2, third is 3. Similarly, this one is -1, -2, -3. Let's suppose this is denoted by Z1 with degree of freedom of 1. What is degree of freedom? So we can consider degree of freedom is something like that. For example, if we have 4 variables, then minimum how many variables do we need to derive the fourth variable? Let's suppose we know the sum of all the variables. So there is x1 plus x2 plus x3 plus x4 is equals to x. Let's suppose. Then how many variable do we need? We need at least 3 variable to derive the fourth one. Okay. So this is this way we can understand the what is degree of freedom. So here in this example, when we are considering this Z1, here the degree of freedom is 1. So in that case, if we do the square of Z1, what do we get? We will get a graph something like this. Here it will be 0. So what is the 1 square? 1 square is 1. Minus 1 square is also 1. Similarly, -2 square and 2 square is nothing but it's an 4. Similarly, 3 square and -3 square is nothing but 9. If we plot this, we will get a graph something like this. So this is chi-square distribution with degree of freedom 1. Let me erase this. So what we can say? We can say that chi-square is nothing but it's a observed frequency minus actual frequency, expected frequency square divided by the expected frequency. So this is, we can also say that the test statistics for chi-square test is z square is equals to summation of f of o minus f of e square divided by f of e. Let's move on to the next slide. Before that, let me remove this. So moving on. Now let's look into what are the conditions do we need to have before applying a chi-square test. So in the statistical test, whenever we are applying any statistical test, we need to take care of that. What are the conditions and whether the data set is following those conditions. If it is following those conditions, then only we can apply the test. Otherwise, we cannot. So let's see what are the conditions we need to follow in case of chi-square test. So it says that the total number of frequencies should be larger than 50, or it should be at least 50. So sum of f of observed should be greater than or equal to 50. The total summation of observed frequency and expected frequency should be same. So what does it mean? Let's suppose that there are some frequencies for observed frequency and there are some values for expected frequency. The summation of f of o should always be equal to the summation of expected frequency. Okay. Now our third condition says that any expected frequency f of e in any group should not be less than 5. So what does it mean? F of e should be greater than 5. Okay, each value should be greater than 5. And another condition is that in chi-square test, since it's a non-parametric test, and we know that in non-parametric test we don't have any information about the population, so here we will have no information about the population. Similarly, the sample collected for experiment should be random. We already discussed what is sampling and what is random sampling, and whenever we are applying any statistical test, we need to take care of that the data which we are picking should be random. Now let's move on to our next topic, that is properties of chi-square test. So the first property says that chi-square chi-square value is non-negative. So we can say that x square is always greater than or equal to, should be greater than or equal to 0. It cannot be a negative number. So this is our first property. The second property says that the shape of chi-square distribution is dependent on the degree of freedom. The third property says that the degree of freedom and the mean of chi-square chi-square distribution is same. The fourth and the last property is variance of chi-square distribution is twice the degree of freedom. So what is this? Variance is equals to 2 times degree of freedom. Okay. Now let's try and understand what are the applications of chi-square test. Chi-square test has basically 4 type of applications. First, chi-square test of independence of attributes. Second, goodness of fit. Third, test of homogeneity. And fourth is feature selection. Goodness of fit. In goodness of fit, we try and understand how a certain proportion fits our sample. Whenever we get a data where we can see that there is only one row, and in that row we have various columns present that are categorical columns, but however we have only one row present, in that case we can say that this is an example of goodness of fit. For example, let's consider a passenger train example. Suppose an organization wanted to know what are the proportion of passengers traveling on weekend as compared to weekdays. So here we can see that weekend and weekdays are two variables. However, the count of or the frequency of the travelers is into a one row. So we can say that this is an example of goodness of fit. Chi-square test cannot be used only when we have one categorical variable. It can be used when we have multiple categorical variables. So in case of multiple categorical variable, we try and understand whether these categorical variables are dependent on each other or are they independent on each other. For example, let's suppose there is a pizza outlet in your city, and the company owner or the outlet owner wants to know whether people like pineapple on pizza or people like pineapple on pizza with soda. So here we have two categorical variables, and we can see that with this example, we can identify whether people like uh, pineapple on pizza with cold drink or whether people like only pineapple on pizza. Another example of chi-square test is test of homogeneity. In homogeneity, we test to identify whether the two samples which are selected are taken from the same population or not. For example, let's suppose an survey team wants to know what are the minerals are present in an water within an area of within a radius of 1 kilometer. So they will choose like different locations water, and they will identify those materials whether they have all the minerals same or not. Based on that, they can say that these water are from a same source or these waters are not from a same source. Similarly, the fourth application is feature selection. In feature selection, we can say that when we train a machine learning model or any statistical model, the feature selection is one of the vital and most important properties, or we can say most important step. In feature selection, what we do, we select all the features. Then on those features, we apply various statistical methods or machine learning methods. Based on that, we identify what are the important variables with which we can train the model so that we can get a correct predictive output. So this is an example of feature selection. So now let's see what is p-value. People often consider p-value as a probability. However, they are related to each other, but they are not same. A p-value is used to determine the significance of our result in relation to the null hypothesis when performing a statistical test. The p-value ranges from 0 to 1. A small p-value is strongly indication that you should reject the null hypothesis. However, if it is towards 1, we can say that we cannot reject the null hypothesis, or we can say that we can accept the null hypothesis. Let's try and understand this with an example. Suppose Peter is a mathematics student, and he has an ideology that whenever he listens to music, he can solve more calculus problems than when he is not listening any music. So can we say that while listening music, all the people can solve more maths problem as compared to when they are not listening any music? We cannot say that. So in order to do this, what we can do, we can perform a hypothesis testing. So we will gather a sample of mathematics student, and then we can get them whether they like to listen music while solving a maths problem or not. And based on that, we can create a contingency table, and from that contingency table, we can say that we can perform a chi-square on top of that. And from that chi-square test, what we can do, we can get a critical value with the help of chi-square distribution. So with this chi-square distribution, if we can see that the p-value is smaller than or equal to 0.5, we can say that we can reject the null hypothesis. Or else, if it is not less than or equal to 0.05, we can we cannot reject the null hypothesis. In that case, we need to accept the null hypothesis. That is, we have to agree that when people listen music, they solve more math sums as compared to when they do not listen music. Now let's move on to our next topic, that is steps to calculate chi-square test. In order to calculate chi-square test, we need to follow certain steps. The first step is to calculate the expected frequency, that is f of e. Then we will find the difference between the observed frequency, that is f of o, and f of e. So that is observed frequency minus expected frequency. Then next we will do square of f of O minus f of E. The next step will be we will divide this square with the corresponding expected frequency. That is f of observed minus f of E square whole divided by f of E. Sorry, f of E. And then we will add all the quotient in the step 4. That is nothing but the next step will be summation of f of observed minus f of expected square divided by f of E. Now let's try and solve some of the examples of chi-square test. So before we go and solve chi-square test problem, let's try and understand how do we solve a test of independence test. So let me choose the pen. So now here first we will see how we can perform the test of independence test. Chi-square test independence is used to determine whether two nominal or ordinal variables have any relation or not, or we can say whether they are independent or they are dependent. So now let's see, before we go and solve a problem, let's see how we can calculate the expected frequency. So here we have this variable 1, variable 2, this is row wise, this is row wise. So we have 2 rows, 2 columns. So it's a 2 by 2 matrix we can understand, or 2 by 2 table. So now we can see this is row wise, this is column term. So row term, like row term is V1 plus V2. That is sum of V1 plus V2. Then this row term is V3 plus V4. Then this term is V1 plus V3. This term is V2 plus V4. And total n, total number of total sum of V1, V2, V3, V4 is variable 1 plus variable 2 plus variable 3 plus variable 4. So now our expected frequency is nothing but E is equals to RT into CT divided by N. So total sum of this column term multiplied by this row term total divided by N. Then we will get expected frequency. Let me clear this before moving to the next slide. Moving on to the next slide. So we can calculate the expected frequency of variable 1, variable 2, variable 3, variable 4 as for variable 1 plus variable 2, multiplication of variable 1 plus variable 2, 3 divided by variable 1 plus variable 2 plus variable 3 plus variable 4. Similarly for variable 2, we can calculate this likewise, variable 1 plus variable 2 multiplication by variable 2 plus variable 4 whole divided by variable 1 plus variable 2 plus variable 3 plus variable 4, or we can call it n. So likewise for this divided by n, this term divided by n. So this way we can get the variable 1, variable 2, variable 3's expected frequency. Earlier in this video, we discussed about degree of freedom. So we discussed that degree of freedom is nothing but the total number of uh, variables required to find the second variable. So in this example, since we have two variables, it's the number of variables are two categorical variable, categorical 1, categorical 2. So we can say that with only one variable, we can identify the second one, or we can use this formula to identify the degree of freedom. That is number of rows minus 1 multiplication by number of columns minus 1. So number of rows are 2 minus 1 multiplication of number of columns, that is 2 minus 1, that is 1. So we can say that for this example, degree of freedom is 1. Now let me clean this. Moving on to the next slide. The next is to calculate the hypothesis. So first we will, the next step will be to just define our hypothesis. So our hypothesis says that calculated x square is lesser than tabular x square. In that case, we can say that hypothesis accepted. So that null hypothesis, this is null hypothesis is denoted by H0. Okay, so we can say when both are independent, when variable 1 and variable 2 are independent of each other, then we can say that null hypothesis is accepted. When they are dependent on each other, in that case, we can reject the null hypothesis. We can reject the null hypothesis. Sorry, this is H. We can reject the null hypothesis and we can accept the alternate hypothesis. So, what is that? When we calculate this x square, our calculated x square is smaller than the tabulated or the tabular x square, that is predefined x square. If it is lesser than this, we can say that we can accept the null hypothesis. If x square is greater than table x square, in that case, we can say we can accept alternate hypothesis, or we can say reject null hypothesis. Clear? Now move on to the next step. Now let's solve an use case. Suppose we wanted to know whether there are any relation between a soda and fries. Suppose we wanted to conduct a survey data from a we connected data from a restaurant. Suppose we have total sample size of 4040, and the contingency table or the frequency table for the same is this. Now first we will calculate the expected values. So type of drink, cola or orange soda. Similarly, fries, whether they like fries or they don't like fries. So the row-wise total is 20 plus 792, that is 812. Similarly, 220 plus 2216 is 2436. Column-wise, we can see that 20 plus 220 is 240. 792 plus 2216 is 3008, and the total sum is 3248. Moving on to our next topic, which is chi-square test using Excel. In this section, we are going to solve an chi-square test problem using Excel sheet or Google spreadsheet. So without wasting any time, let's open our Excel sheet. Now let us suppose we wanted to identify a relationship between a summer and a winter and COVID and no COVID. So we wanted to know whether there is any significance on the weather on disease COVID or not. So for that, our observed frequency table is this. Next, we will calculate the row terms, we will calculate the column terms, then we will calculate the expected frequency using those row and column term as we have solved it in earlier uh, slides. Then we will calculate the observed frequency minus expected frequency and their square. Then we will calculate the calculated chi-square test, and then we will calculate the chi-square value tabulated one using a chi-square distribution sheet. So without wasting any time, let's get started. So for this, we will calculate the sum of these two. Then we will calculate sum of these two. Now we will calculate sum of these two values. Now we will calculate sum of these two values. And we will also calculate total sum of the values. So total sum of the values is 800. Using these values, we will calculate the expected frequency. So now let's calculate E5 multiplication of C7 divided by E7. For the second variable, E5 multiplication of D7, E5 multiplication of D7 whole divided by E7. We have calculated the expected value for the second one. Now let's calculate the expected value for the third one. E6 multiplication of C7 whole divided by E7. Similarly, E6 multiplication of D7 whole divided by E7. That is this. Now we have expected value, we have observed value. Now let's calculate the square of observed minus expected. So we will calculate our observed value is 30 minus 15 square. Now we will calculate the other one, that is 270 minus 285 square. Then we will calculate the another one, that is 10 minus this C6 minus 25, that is coming 225 is equals to 475 490 minus 475 square, that is 225. Now we will calculate the calculated chi-square test. So our calculated chi-square test will become is equals to 225 divided by 15 plus 225 divided by 285 plus 225 225 divided by expected value, that is 25 plus 225 divided by this expected value. Now let me add one more bracket and one more bracket here. So now we can see that it's coming 25.26. Now in order to calculate or in order to find out what is the tabulated chi-square value, we will use a chi-square distribution table. So let me show the table. Since we know that there are two variables in this problem statement, so the degree of freedom will be total number of variables minus 1, that is 1. So our degree of freedom is 1, and whenever we are not given any confidence level, so that means it's a 0.05. So in this case it is coming 3.84. Now let's write it down, 3.84. Now we can see that calculated chi-square is greater than tabulated chi-square. So let me highlight this. So from this, what we can conclude? We can conclude that we can reject the null hypothesis. Null hypothesis. Now let's calculate the p-value for the same. So in order to calculate p-value, we will go to formulas tab. In that formulas, we will go and type insert function. Here, if we go down, just go to all and then type chi-square and go. Then we can see that there are chi-square test. Okay. So we will choose this chi-square test. Go to this actual range. This is our actual range. And now go to our expected range. Our expected range is this. So now we can see that the p-value is lower than 0.005. So now we can unlock 0.05. So now we can say that we can reject the null hypothesis with the help of p-value, as well as from the tabulated chi-square test and the calculated chi-square test, we can clearly see that calculated chi-square test is greater than tabulated chi-square test. So we can say that we can reject the null hypothesis. Now let's move on to our next topic, that is chi-square test using Python. In this section, we will be solving chi-square test using Python programming language. I would highly recommend you to go through the GLA course where you can find videos related to Python programming language, Anaconda, and Jupyter Notebook. For this exercise, we will be using Anaconda environment and we will be using Jupyter Notebook. For this use case, we will need some of the packages that are Python, pandas, scipy, numpy. In order to execute those codes, you need to have those packages installed in your system. So without wasting any time, let's get started. Once you install Jupyter Notebook and you open it in your system, you will see that it will be open in your browser. So once it will open, it will look something like that. You'll go to your designated folder, and in that folder you will see IPython file. So in those IPython file are nothing but these are simple notebook. We call it notebook. In these files we can write anything, whatever we want to write, how beautifully you wanted to write, you can write any like that. Okay, so it's a notebook. So in this example, we will be solving one chi-square test. So some of the packages which will be required for this are listed here. So you can download them using pip command. If you don't know about pip command, how pip works, I would again highly recommend you go to the GLA course links and you will find there various courses related to Python, related to Jupyter Notebook, related to Anaconda. So now let's get started. First, we will load the packages. So in order to execute any cell, either we can click on run or we can simply press enter and shift. So now our first query executed. Now we have imported all the packages that are necessary for our exercise. In this exercise, we will be using Titanic dataset. We all know the tragic Titanic ship and the story about it. So here in this example, we will be taking some of the examples dataset taken from Titanic history, and we will try to apply the chi-square test here. So now loading the data has been loaded. Now let's see how the data looks like. The data is something looking like that: survived whether people survived or not. 1 is for survived, 0 is for not survived. What is the P class? What is the gender of the person? Age, SIVSP, Parsh, fair, embarked, class, who, whether it's a man or it's a female or woman. Adult male, is it adult male or not? Deck, embarked, alive, and alone. Okay, so now moving on to the next thing. So now we will create a contingency table from this, where we are taking two columns. One is gender and another one is embarked. So now we will use the cross table from pandas. With the help of that, we will create a contingency table. So now here we can see that female, which is C, that is 73, female, which is Q, that is 36, female, which is S, that is 203. Similarly, male with C embarked, that is 95, male with Q embarked, that is 41, male with S embarked, that is 441. Now let's get the values from that table. So first I'll execute this code. Now we have that table ready. Now we will get those values into an array. So this is an array. So now we will get the observed data. So observed data are nothing but the data table dot values. So execute this. So we have now the observed values. Now we will use the start state, this scipy file. Okay, and from this we will use stats function. So from that stats function we will call chi-square contingency table. Okay, so now we will calculate this. So we will get a value. So now we will calculate the expected value. So here it's a combination, it's a tuple where we have expected values and we have other values also. So we will get the expected value into a column. So now we have expected value. Then we will calculate number of columns, number of rows. Based on that, we will calculate what is the degree of freedom. And as we have already discussed multiple times, that whenever we see there is no alpha value given, we will consider it to be 0.05. So now calculate the degree of freedom. As we know that it's a two variable problem, so we can say that the degree of freedom is 1. 2 minus 1, that is 1. So now we will calculate the chi-square value. So for that we will use scipy dot stats. We will import chi-square. Now let's calculate this. So now we can see the chi-square statistics is minus 9.44. Now we will calculate the critical value for that. Now we can see that the critical value is coming 3.841. So we will calculate the p-value from that. So now we can see that the p-value is 1 minus chi-square CDF function, and here we will pass this chi-square statistics, and DF is the degree of freedom. So from that we will get the p-value is this. We will get the degree of freedom or significance level as 0.05. Degree of freedom is 1, and p-value is very lesser, is very near to 0, or we can say it's close to 0 or less than 0.05. So we can reject the null hypothesis. So here we have created a if else statement. So if chi-square test statistics is greater than or equal to critical value, we can say that we can reject the null hypothesis. Else we can say that we are not able to reject the null hypothesis, or we are failed to reject the null hypothesis. Similarly, if the p-value is less than or equal to alpha, we can reject the null hypothesis. If it is greater than alpha, we can say that we are not able to reject the null hypothesis. So in this case, we can see that clearly our chi-square statistics is greater than the critical value and p-value is less than or equal to alpha. So we can reject the null hypothesis. Now moving on to next topic, that is chi-square test using R programming language. In this programming example, we will be solving goodness of fit. So without wasting any time, let's open our Jupyter notebook. So now our Jupyter notebook is open, and now let's come to this notebook. Here I have created a notebook earlier where we will be checking or identifying whether there is any significance difference between the number of travelers traveling across the different weekdays. So now for that, this is our contingency table. So now we will create a vector for this. Executing this code. Now we have our vector ready: 1124, 1125, 1110, 1120, 1126, 1115. Now, in order to calculate chi-square test in R programming language, what we do, chi-sq dot test, and then we pass the data. So now execute this. Now we can see that our p-value is coming 0.99 for this, and degree of freedom is 5, and x squared is, or the chi-square value is 0.18. Since we can see that the p-value is greater than 0.05, so we can reject the null hypothesis. Now let's take another example. Suppose this is the vector data. Now create a vector from this data, and now our data is ready. Let's view this data. So now our data is 40, 25, 19, 37, 39. Now let's call this chi-sq.test and we'll pass this data. So now when we will pass this data, we will see our chi-square value is coming chi-square value is coming 11.125. Our degree of freedom is 4. P-value is coming 0.02. Now in this case, we can see that our p-value is lower than 0.05. So we can see that we can reject the null hypothesis. Now let's move on to our next topic, which is feature selection using chi-square test. For this problem, we need to have scikit-learn installed in our system. So if you don't have scikit-learn installed in your system, you can install it using pip command. Now, feature selection is one of the very important step in machine learning or any statistical modeling. So what feature selection does? In feature selection, with the help of which we can identify that which are the variables which will help us in predicting a output variable. So with the help of that, we can select those features only, and on top of those features, we can train our model and we can get the best result out of that model. So without wasting any time, let's get started and see how we can do the feature selection using chi-square test. Now we have our Jupyter notebook open, that is feature selection using chi-square test. For this exercise, we will be using the same Titanic dataset. So first, we will import Seaborn, and then from that Seaborn, we will load a dataset named Titanic. Now let's load this. So our data frame is now loaded. It has 15 columns, 891 rows. Now we will just select those features which are important to us, like survived, P class, sex, sibling, embarked, adult male, and alone. If you see clearly, here we have all the features that are categorical in nature. We are keeping them only, and we are removing the numerical variables. So now we have our data, that is filtered data. Now we will use scikit-learn. We will import scikit-learn. From there, we will import pre-processing. And in that pre-processing, we will do the label encoding. So here in survived, P class, siblings, we have the numbers. But however, in sex, embarked, adult male, and alone, it's a textual data. And in order to execute anything in machine learning, we need to convert any textual value or any string value into numbers. So with the help of label encoder, we will assign them a unique value. So all male will get, suppose for example, 0, and all females will get 1. Similarly, for embarked case, let's suppose S will get 0, C will get 1, and Q will get 2. Similarly, adult male, true will get 0 and false will get 1. Similarly, for alone, true will get 0, false will get 1, or vice versa can be possible. So now just do the label encoding for each of the columns. So now we can see that P class is not converted into numbers. Similarly, sex is converted into numbers. Now we can see that these are all converted into numbers. Now we will do it for the embarked, adult male, and alone. And now let's see how our data looks like. So now we can see that all the variables are in numerical form. Now we will divide it into x and y. That is, all the variables except the survived will become our x and y will become survived. So now filter them out. So this way we have our x and we have our y. Now let's print them out. If we print our x, we will see that this, but not the survived column. And in y, if we print it, we will see survived. Now we will use scikit-learn's feature selection import chi-square. This function helps us in identifying the variables which are important for us. So from this, let's execute it. And now we will calculate the p-value, and those p-value we will be storing into a data frame. So now do this. And now we will sort them by by descending order. So now we can see that the p-value for each one, and from these p-value we can identify the variables which are important to us and the variables which are not important to us. This is one of the feature selection technique which we use in machine learning or statistical modeling. Now let's discuss some of the advantages and disadvantages of chi-square test. Let's first go ahead with some of the advantages. So chi-square test helps in feature selection. In the earlier slide, we saw how we can perform the feature selection and how it is important for machine learning and statistical modeling. Similarly, it helps in identifying the independent group of data. We have seen 2-3 examples where we tried to identify or try to establish a relationship between the two variables or try to identify whether the two variables are related to each other or not. It judges how well our observed data matches the expected data. For example, in goodness of fit, we saw this example. Okay, in goodness of fit, with the help of goodness of fit, we can identify or we can judge how well our observed data matches with the expected data. Similarly, there are some of the disadvantages which chi-square has. Now let's discuss some of them. It does not give any information about the population. So what kind of information? It does not give any mean, it does not give you median. These kind of information we cannot get it with the help of chi-square test. If the expected variable in a cell in a table is less than 5, chi-square test lead to incorrect conclusion. As already we have discussed that frequency of expected should be greater than 5. If it is less than 5, we cannot apply chi-square test, or if we apply it, we will get a bad result. Another example, another disadvantage is, in order to execute chi-square test, minimum number of samples should be 50. If the total sample size is less than or equal to 50, we cannot use this. This has to be greater than or equal to it. This has to be, sorry, this has to be greater than 50. Okay. So these are some of the advantages and disadvantages of chi-square test. Now we will discuss some of the limitations of chi-square test. So for chi-square test, the data must be a frequency data. As we have seen in all the examples, we should have at least a contingency table in order to execute chi-square test. The data selected for sample should be random. the selection of the data process should be random. We have seen this. Now, coming to the third limitation, chi-square test is sample size sensitive, due to which, with increase in sample size, strong association may not come up as significant as they are. So this is one of the very big limitation of chi-square test. Another limitation is if the expected frequency in a cell in a table is less than 5, chi-square test can lead to incorrect conclusion. Summary. So now we have completed our syllabus for chi-square test. So in this video, what we have covered in this video, we covered what is the statistics. We got to know that statistics is very powerful tool. This helps us in prediction of variables. Okay, then we got to know what is population, what is sample, what are the various types of sampling techniques available. Then we also discussed continuous variables and discrete variables. Then we discussed what is parametric and non-parametric test. Then we covered what is hypothesis testing, what is chi-square test. Then we discussed some of the application and properties of chi-square test. We also discussed what is p-value and its significance and how we can get the p-value using chi-square distribution. Then we also see some of the examples where we calculated chi-square for various problems, and based on that we either rejected or accepted the null hypothesis, and we got to know when and at what situation we should accept the null hypothesis or we should reject the null hypothesis. Similarly, we solved a use case. Similarly, we solve an problem statement for a chi-square test using Excel sheet, using Python, and using R programming language. We also discussed some of the advantages and disadvantages of chi-square test, like minimum number of frequency that needs to be there, the total number of sample size that needs to be 50 or more than 50. So these are some of the disadvantages which we discussed, and we also discussed some of the advantages that with the help of that we can identify is there any relation between two variables or not, or we can identify how good it can fit. So goodness of fit we got to know. We got to know about independence of two variables. We also discussed about feature selection technique, and we also discussed about some of the limitations of chi-square test. So that's it from this video. I hope you enjoyed this video. So keep learning, keep growing. Thank you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.